What would you guys say I should do to solve for that A? Right. So using our inverse operations, we divide by z, and you have A on the left, and the z's are factors, right? And so like those factors divide out, they equal 1. So it's like 1 times A, that's really where they go. Okay. And then on the right side, we got C over Z. Okay. So the only thing that I would maybe ask you a little bit once we get into more complicated ones is like decide what to do and then write down your result. Okay. All right. So for that A. Now, if I distribute the A, we're going backwards. We're not solving for A, we're distributing the A, so we're getting more A's. We don't want that. We want to get everything away from it. Right. So something that you maybe haven't done much is you haven't divided by a quantity. But if I've got a factor of B plus C in the top, let's put a factor of B plus C in the bottom. And just like these factors of Z canceled out, these factors of B plus C are going to cancel out. Okay? So then you get left with A equal to D over quantity B plus C. Okay, the next one. We're solving for A, but there's A's in 2 different places. Distribute it out, factor it out. Okay, very good. So if there's A's in 2 spots, undistribute that A, and then it's the same problem as the last one. So now you divide by the quantity B plus C. Okay, so I don't want to see it. Like I kind of see some people that do this. They go A plus B, A plus C equals D, and then they divide by B plus C. Well, I don't want to see that. Okay, because I don't know if you know what the heck you're even doing. You need to factor out the A and then divide by B plus C. If you don't show me both steps there, I won't give you full credit. Because it's really kind of a two-step process. So now, my point is that 3 and 2 are the same problem. It's just here it wasn't undistributed first, here it was. So you really should go from here to here to be able to do that problem, okay? Anybody got any issues on that? Okay. All right, I'm taking guesses for how to start problem number 4. I like the guesses. I'm going to say that's not how I want to start number 4. Multiply what? I'm going to multiply by something, but I'm not just going to multiply by A. I'm going to multiply by ABC. Okay, so what kind of equation is this? This is a rational equation, and when you have a rational equation, you want to start by getting rid of the fractions. So we multiply by the least common denominator. So that's going to be CAB, CAB, and CAB. So we're multiplying by that everywhere. Okay. Can you, like, if you had an equation, could you square each part? You couldn't square each part. You can't do that. You got to square the quantity. Here, you can multiply this, this, and this because it's like distributing over a plus. So what's left on the left side of the equals? A times B. And over here you would have a and an A cancel, so you have X times C times B. And then here you have a Y times C times A. Tell me what's going on here. Are we okay? Canceling the A's here, or canceling the C's here, canceling the A's here, canceling the B's here, right? So now we don't have any fractions, okay? So now we still have the same job. Our job is to solve for A. It's even worse than this problem. There's two of them, but they're on opposite sides. Get them on the same side. How? Subtract what? Very good. So like, think of this as a term, and you can like subtract that term, and then it would become the opposite sign on the other side, right? Even though it's 3 long, you wouldn't want to divide by YC because you can't, like, this is what I think probably some people think that they would want to do is divide by YC, maybe, I don't know. First off, that doesn't get rid of the A, you know. My goal is to get the A on one side and then factor it out so I can solve for it. So I shouldn't even gone that direction, I guess, but let's do what you guys said, which is to subtract YCA. So AB minus YCA equals XCB. Where do these go, by the way? Why are they gone? Because they add up to 0. Because this thing and this thing add up, they're opposites. They add up to 0. So it's really a 0 there. Okay, so now factor out the A. So if I factor out the A, what do I got? Very good. So again, factor it out on either side of the minus, or the plus if there was a plus there. And then divide by, very good. So we'll talk about this a little bit more. Where do the b minus y c's go? They cancel out because they equal 1. So this and this is 1 times a. So you have a on the left, and you have this on the right. Is the top factored? Yep, it's x times c times b. Is the bottom factored? B minus y times c. Are they all factors? Y minus c yc. B minus yc see, my point is that this is a factor, this is a factor. That's not a factor because it's not multiplied times the other stuff. Okay, so since this is not a factor, you have not factored the bottom, therefore you can't cancel factors in the top and the bottom. Okay, so I cannot do this and this. Okay, they're not factors. Okay, you can only cancel factors. Now, can there be factors within? Can you have a plus sign within factors? Absolutely. Raise your hand if you think that this is factored. Raise your hand if you think that this is factored. Raise your hand if you think that you can cancel out factors. Okay? Is this a factor of the bottom? No. So then don't cancel it. Okay? So for the most part, don't simplify anything, and you can't go wrong. I won't mark it wrong if you don't simplify it at the end, because I just don't want you to do something wrong. Okay? So again, the key rule is you can only cancel things in a fraction if they're factors. Okay? All right. Rational equation. Tell me what to do. Say again.
Multiply by A.
Okay. That's absolutely one option, and that will get the right thing for you. What would have been another option at the beginning? And if you cross multiply, you get B times E equal to ACD. Okay? So BE equals CDA. Okay, now what I want to do is I want to solve for A. So give me a thought there. Right, so you can divide by that entire pair of letters, because those entire pair of letters equal 1 when you divide it. Okay, so you have A equal to B times E over CD. Okay, so let's look at the next one here. There I've got a radical equation. So I've got a 1, I've got an x, I've got a division, and I've got a square root around the a. What would you say might be the furthest thing away from the a? The square root. Okay. So then what I'm going to do is I'm going to square both sides to get rid of my radical sign. So that would be what I would suggest to do first. I don't know what else you would do. Probably could do some things, but this is going to get rid of it and at least get rid of the radical sign. See, I know how I'm looking at it. I don't like that. That's how I'm looking at it. I don't want, basically today, if you see an equation with fractions in it, get rid of the fractions before you start solving for the variable. So tell me what I think we should do here. Right, so XA is the least common denominator, so let's multiply by XA, and that's going to get rid of our fraction. So XA times the right and XA times the left. So XAF squared equals 1. And again, these cancel out because these are factors. It's all multiplication. Now, you might not like this in this form, so I'm going to do this. I'm just going to use the commutative property to switch the x and the a around. Maybe now you can tell me what to do to solve for a. Right, right. So if you understand why these cancel, you're going to understand what to put there so that they do cancel. They cancel because they're factors. So you have a equal to 1 over xf squared. All right, you guys play with number 7 for a while. I'm going to let you come up with something. Good start. Now the only thing is like you're trying to get that a by itself, so I would think about like don't divide by t. See if you can get rid of that. Yeah. So solve for a. That'll work. Very good. That'll work. That'll work. So then you have okay, very good. You might have left it at the end a little weird, but you did all the steps right. So I see some good things here. Okay, so let me do this one here. We'll call it a week. So I see some people cross multiplying here. I see some people multiplying both sides by x x times a plus b. It works out to be the same. So after your first step, everybody should have had something that looked like this. And everybody I saw did. Okay? Now, could you distribute the y through? Absolutely. Okay? So I'm going to do it a couple different ways. So if I distribute the y through, I have xt equals ya plus yb. Now what should I do? Right, so you get rid of the multiplication last, you get rid of the addition first. So I'm going to subtract yb. So it's going to be xt minus yb, and then divide that by y. So if you have that, fantastic. If you want a different direction, you maybe could have divided everything by y and then subtracted b. And that's good too, okay? So let's divide by y. So it's going to be x t over y equal to a plus b, and then subtract b. Now the only thing about it when you put it over here is don't put it over the y. So like just kind of put it all by itself. So x t over y minus b equals a. So either one of those is right. Okay. So you look like you did a pretty good job on that. Okay, so let me just show you one thing on your assignment, and then I'll let you work here. So when you get to the first problem on your assignment, number 81, this is your pressure and volume and temperature relationship. Is that Boyle's law? I think it's Boyle's law. I don't know. Okay. But this is a different variable than this. This is not p squared. This is just a one pressure, and this is a different temperature or different pressure. They're different, right? Okay. So you still cross multiply. So you have T1, P2, B2 equals T2, P1, B1. Does it matter the order that I have these in? As far as like if I put the T on the left, the T on the left or T on the right, it doesn't really matter. Okay. Now they're telling us that we're going to solve for T1. So if I want to get T1 by itself, divide by P2, B2. Right? So it might be a little weird working with subscripted variables for you in the formulas, but they're just different variables. So just treat them like any other variable, that they're just different from one another. Okay. So 81 to 90, page 282. Did I write it down wrong?
Because that doesn't make sense if you. Oh wait, you fixed it and then.
Okay. There's a lot of things I do though, but what makes sense, Elise?